Yes. So, good evening, everyone. And today we are gonna discuss about this paper, free lunch for few short learning distributed calibration. So this is ICLR 2021 paper, and from last previous paper rating groups, we have been seen that what is few short learning. So again, a quick review on few short learning. So in the few short learning, we have a very small number of examples, like one example per class, one image per class, and we want to learn a generalized model for extremely this limited data. Limited data means we have very few images, and then we want to perform the testing task. So here one thing we can do, we can do, like, we have this few example, but can we directly train a classifier with such limited example? So things is no, because it will cause a overfitting, because we have a less number of examples. So then uh, what this paper have proposed. So this paper proposed a simple and distributed calibration technique for few short learning. So the problem we have seen for few short learning, here they have estimated ground truth first for data distribution using single example. So this in first figure, this is a classifier trained with few short example, and then uh, a classifier trained over this distribution to get a better generalization rather than overfitting. We don't want overfitting, that's why we are trying to generalize. Not we, they were trying to generalize on this model in another way. So how they done this task? So they assume that every dimension in the feature vector follows a Gaussian distribution. Whatever feature vector they have, it follows a Gaussian distribution. Then after that, they observe that similar classes usually have similar mean and variance of feature representation. So here in this figure, we can also see that, like, this mean similarity, and this is a variance similarity of white wolf and malamute. So this kind of, like, mean of every class, similar class have similar mean, and they have variance of feature representation. But why they have done this thing? So because we know that mean of a class feature usually indicate the average appearance of the class, and variance on different feature dimension indicates the changing range in different attribute. So here you can see this appearance is a bit change. Here posture is bit similar, and here based on the color. So the data distribution can be transferred across similar classes. So here the problem setting is, first they trained a model and similar that a way that usually model have usually model do. So model is trained on base classes, that they are calling it CB, and this CB, the base classes, let's say you have 10-20 base classes, so which contain many classes with ample example uh, per class. It means it's just a simple, like a mini we have this mini ImageNet data set. So it have 64 classes of 600 images per classes. So this is a not a very few sort example. They have a sufficient example to train. So based on this images, this data set, first training have done, and this few sort things comes into consideration while we are evaluating this model. So during the evaluation, the model is then evaluated on 10,000 times NV case or task. So here, because why it is doing why 10,000 times? to generalize it, to get the generalization ability on few sort classification. At the end, you want to generalize this model so that it will not overfit. And in every T, every n wave case or task, it contain, because this is 10,000, so in every task there it contains training support set, that is called training set, and testing set, that is query set. So the two things it contain. And support set contain n classes and k example per class, like we can say 5-way one shot class. And 10,000 times and make a short task are sampled from these novel classes. So the original classes in which the model have trained and the novel classes that being sampled should not have a common images, so intersection should be 5. So that is novel means different unseen example that not been seen from this training example. So training steps, in the training step, they have first pre-train a feature extractor on base classes. Base classes like on mini ImageNet, uh, and then they have computed this mean and variance, because mean and as we have seen that mean is used for average appearance. So here they are calculating this mean and then calculating this variance. So where xj is a feature vector in this feature vector, and jth sample from the base class. uh, so this is training phase. And in evaluation phase, on a n way case or task, uh, they first extracted features and on this extract support set features. So here support set have images and corresponding labels, and then transform the feature distribution of s. So why this here they are performing this called turkey's ladder transformation. So what is this turkey ladder of power transformation? It is a way to change the shape of skew distribution, uh, that that will help to normalize it. And normalize means finding the more Gaussian way, so that yeah. So this is because they made a strong assumption that all the features from the same class are follows a Gaussian distributions, which may not hold perfectly sometime. So this to this problem they have done this. After that, in their third step, they have calculated this Euclidean distance for top k base classes. So distribution calibration through statics transfer. So for each sample, they find its top k base classes. Right. And then the distribution of the class Y is calibrated by the statics from the nearest base classes. So then in step 4, uh, they have trained a classifier on the calibrated distribution. That distribution already been calibrated. So they sample a set of feature vectors from the calibrated distribution for each class, whatever class they have, each class Y. So classifier is trained over the support set and the generated set. So both set, and here they have find this cross entropy loss over both the feature and its support set. And in the last step, uh, they have find the classification accuracy on query set. So and query set, on the testing time they also applied power transformation, because it also required to check that Gaussian distributions, whether it is making Gaussian distribution or not. So on testing, they also applied power transformation to make the query set distribution more aligned to what they have assumed in previous slide. So the classification accuracy on the query set is computed using the classifier the learn their support set and their generated set. So this is complete algorithm that we have discussed one by one. So this is requirement support set features first, and then base classes, finding mean and variance, covariance, and then transform with turkey ladder power transformation, and then for every x comma y, calibrate the mean and covariance for class yi and using xi. So here that we have seen. And then sample feature for class yi from the calibrated distribution, and then train a classifier using both support set and all the sample set. So data set they have used for this calibrated distribution, calibrated distribution. So for this first data set is mini image net, and second is tired image net, third is cup. So in the mini image net, they have it is derived from the mini image net data set, and it contains thousand 100 diverse classes with 600 sample per classes, and the size of image is also 84 into 84 into 3. So and tired ImageNet dataset is a larger subset of ImageNet dataset. So these are different subset of ImageNet derived from this ImageNet only. So it contains 608 classes sample from the hierarchical category structure. So each class belongs to one of the 34 higher label categories. So this is like about dataset. COV also is a fine-grained few-sort classification benchmark. It contains 200 different classes of words with a total of 11 788 images of size 84 into 84 into 3. Okay, so after that they have some split for this. So first in many investment split of 64 classes, 16 validation classes, and 20 novel classes. But here they split the data set into 51 base classes, 97 validation classes, and 160 novel classes. After that in CUV also they split the data set into 10 into 100 base classes, 50 validation classes, and 50 novel classes. So here are results of they have performed this experiment on three settings. First optimization based setting, second matrix based, third is generation based setting. So compared with these all three settings, they have claimed that their model, this first maximum likelihood were DC model, distribution calibration model, and SVM with DC model, and logistic regression model. The performance of these model is better than the other models with other settings. So this is on mini ImageNet, and this is on CUP. With the first setting is with 5-way 1-shot setting, and another setting is 5-way 5-shot setting, similar for CUP, and also similar for tired ImageNet. So this is also showing that there is a huge improvement over basics, the state of the art models and their model. So Ablation study and hyperparameter are saying that here two things are giving most attention, that is turkey transformation and generated feature, training with generated features. So based on turkey transformation and generated features, this uh, mm, accuracy is giving different values. So when increasing the power lambda in turkey transformation, so accuracy is changing with respect to this generated features. And here opposite setting is done, number of generated feature per class they are taking changing, then test accuracy is changing with respect to turkey transformation and without turkey transformation. So another finally here we can see that with distribution calibration, this improvement of about 12% and 11%, 9.1%, 9.8%, 12%. So on average 10% improvements this their settings are giving without changing their hyperparameter and all these thing extra parameters. So this is what this paper have suggested, and this is a short paper. So anything, any question related to this? It's done from my side.
Okay, so hi Neelu. So my one question is that I have that you said that the main assumption that the authors have made is that the distribution is Gaussian, right?
Yes, yes.
So what has motivated them to make that assumption?
uh, because if the distribution is Gaussian, so I suppose that it will belongs to same classes, like uh, it will be on the same line, that what we call.
So did they think about some other distributions and then using some other techniques to transform features into that distribution much better, like they're using 2K one over here?
No, no, they haven't done this. They already proposed a distributed calibration technique. Yeah.
Like this, that is basically for transforming our features into the into a much Gaussian way,
Yes,
right?
yes,
That's what you're saying.
yes, yes, yes.
Okay. Okay.
So that turning that into a Gaussian base will get a better generalization and will not overfit that, and will not need much more examples also of in case of few short learning.